Okay, I am here. All right, hi, I'm back. Right now it's 11:40. I'm gonna give it a couple minutes for everyone else to rejoin. All right. So, in working and watching the teams, I would say about 75% of my students are doing what I'm asking as far as the teamwork goes. So basically what I'm asking is I'm asking you to, in your teams, ask questions like, what problem are we doing? What is the problem? What should we do first? What should we do now? What did we get? Those of you who are doing what I'm asking, I think you're starting to understand how powerful it is to actually work together rather than working separately. The other 25% of you are not doing what I'm asking, and I can't help you. If you do not do what I ask, I can't help you. You're tying my hands. So anyhow, I just wanted to thank all of you who are trying to do what I want, because you will eventually find out what I'm trying to do, and it'll be highly beneficial for you. And the rest of you, please trust me and fall in line and do what I'm asking you to do. Just try what I'm asking you to do so that I can prove to you that, or show you how to effectively collaborate. Okay, you being in a group and just working individually does not work. Remember, I'm 40 years older than you. So I've been around the block a few times with math and working in groups. And I'm trying to teach you something, but if you don't try to do what I'm asking, you're never going to find out what I'm trying to do with you. So, but those of you who are doing it, you're finding out what I'm talking about. Okay, so at this point, I would like to field questions that you have, because there should be a bunch of questions on this. So does anybody want to ask me any questions about P6?
Yeah, for 17, one of the answers is 0, and how did they get that?
Okay, let's do 17 because a bunch of teams have asked me about this. All right, this is multiplication, which means we do not need a common denominator. And what else that means, we have to factor, and factor some more. So do you guys recognize what this is? What factoring method that is?
The sum of squares?
Difference. Yep, it's the difference of squares. And if you recall, the difference of squares was that little format that I wrote. And I said that you could write it as the product of a sum and a difference. And that would be x and 3, x plus 3 times x minus 3. And that was the one that I said that a lot of students are just going to guess on. That can't be factored. What's this method? What factoring method is that?
And GCF?
Yep. So you take out an x times what is that? X times what is that? So this is x times x minus 3. And then last but not least, isn't this factoring method 5? So don't we need what multiplies to give a negative 12 and adds to give 1? So wouldn't it be 3 times 4 where the 3 is negative? So wouldn't you write the answer? Any questions right now?
For the x squared, how come you didn't put x times x? You just left it as x squared.
We can. We can if you want. We can. That's a good idea. Yeah. That's a really good idea because we can cancel an x, right? And we can also cancel an x minus 3. So what's left? Now, you're going to have to practice those globes. So for problem number 17, I would practice in the online textbook. I would practice the globe on 17 because are they going to leave the answer like that? Or are they going to FOIL it out? See, I would have you FOIL this out and distribute. So if you were with me in the classroom, I would make you do this. But for some reason, because this is a high level class and they're going to assume you know how to FOIL and distribute, they're going to allow you to leave it like that, but you got to do the online problems to find out. So if you don't do the online problems, you could possibly get it wrong on the exam. The question is, which one is it? This one? This one? For me, you would have to go to this. All right, now the next problem I'm gonna have you do it, but do you guys have any questions about any of these steps? Okay, let's look at another problem. What do you want to do?
Number 33.
Okay, that's adding. So remember, when you're adding, you have to have a common denominator. So I want you guys to do this. So everybody write this down in your notes or scratch paper, and I want you to try to do it. I'm going to give you a couple of minutes to look at it. Okay, it's 4x plus 1 over 6x plus 5. And we're adding 8 plus 9 over 6x plus 5. So you do have a common denominator. So you have a common denominator. So you're good to go. Go ahead and do the numerator. And I'm going to give you a couple minutes. I'm trying to build your confidence here. So. All right. So what did you write in the numerator?
12x plus 10.
Twelve x plus 10. Well, look at this. Doesn't this look like you could do a GCF and something might cancel? So doesn't this look like you should factor out a 10, do a GCF? And sure enough, look what happened. So you can simplify this just like you simplify 2/4 to 1/2. You always have to look at your answer. And if you can factor or simplify, you have to simplify. Now let me tell you what you cannot do. You cannot cancel the 12 and the 6. You cannot cancel the 5 and the 10 the way it is. The only thing you can do is a GCF and cancel the way I'm showing you. There is no other way to do it. So if you didn't do it exactly like this and factor out a GCF, you did something else. Whatever you did is incorrect. This is the only way to do this correctly. Go ahead, I'll take questions. Questions about this problem?
So is the answer the one on the right or the one on the left?
This is the answer. This is the
Okay.
answer. And the excluded value, they didn't ask for it. But if they ask for it, 6x plus 5, you can't have a negative 5/6. And how do you know that? 6 times negative 5/6 is negative 5 plus 5, which is 0. So you cannot have a negative 5/6 throughout this whole problem. If you don't want to guess, you could take 6x plus 5 and set it equal to 0. Subtract 5 would be negative 5, divide by 6. X is equal to negative 5/6. So I don't care how you do it. You can either guess or you can set it equal to 0 and solve it. This is not the answer, though. This is not simplified. And you will get it wrong if you leave it like that. You have to simplify everything. So how did I know to do that? Because 2 is a common number. And if you just almost do it here and take out a 2, you see you're going to get that 6x plus 5. So you gotta pay attention to your answers and see if you can simplify more. Okay, go ahead. Let's do another problem.
I have a question. So for subtracting, that's when you distribute the numerators?
Yeah, let's do one of those. Let's do problem number 43. It's 3 over x plus 1, put simple binomials in parentheses, minus 3x. 3 over x, sorry. All right, now some students look at this and go, okay, what's he missing? He's not missing an x, he has one. Oh, he's not? This guy is tagging along with him. So there is no single x. So you don't see a single x, so he needs one. And this guy, you can't just add 1. That doesn't make any sense. He's missing an x plus 1. So we have a common denominator. So the common denominator is x times x plus 1. Okay, now you guys unmute yourself and tell me, what do you get on the top? Now remember, you have to distribute a negative 3. So what do you get on the top?
3x plus 3.
Say it again. 3x what?
Negative 3x minus 3.
Yes. It's negative 3x minus 3. Good. So these are true opposites. So these two cancel. And you end up with negative 3 over x times x plus 1. And like I said, on the computer, they may want you to leave it like that. If you were with me, you would have to multiply this out to x squared plus Now, they did not ask for the excluded values, but if you were to write them, x cannot, by the way, this is equals and this is not equal. So what, unmute yourself and tell me, what can x not be? X cannot be what?
1. Negative
Say it
1.
again.
Negative 1.
At 3.
It's right here. No.
X.
What can x not be?
A negative x.
0,
Oh, 0.
right? Go ahead. X cannot be
0.
0. X cannot be
0.
over here.
X minus
-1, right? X cannot be you have to look through the whole problem, right? Don't you have to look at all the denominators? Yes. So tell me, x cannot be -1, x cannot be 0, x cannot be 0, x cannot be -1, x cannot be 0, x cannot be -1, x cannot be 0, x cannot be -1. We got them all. Right? Don't make this harder than what it is. This is the easiest thing we're doing right here. All you're doing is looking at what makes the denominator 0. -1, 0, 0, -1, 0, -1, 0, -1. Right? Okay, moving along. Do you guys want to do a complex fraction? You want to do a division problem? So you tell me, I don't know what you need. Do you want to do problems 1 through 6, 7 through 14, multiplying or dividing, adding or subtracting, or complex fractions? Take your pick.
Complex fractions.
Okay, number 59. You have x over 3 minus 1 over x minus 3, which is a simple binomial. Well, don't you need a common denominator on the top? So don't you need to multiply that by 3 over 3? So this guy floats along. And on the top, don't you have x divided by 3 minus 3 over 3? So isn't this common denominator 3? And in the numerator, you have x minus 3. So now don't you take the stat and lay it out flat? So wouldn't that be x minus 3 over 3 divided by x minus 3 over 1? Isn't it this fraction divided by that written as a fraction? So now we change it to multiplication and take the reciprocal. So this would be 1 over x minus 3. So who cancels? So isn't your final answer 1/3? And they're not, I don't think they're asking you to write an excluded value, but wouldn't the excluded value just be 3? You guys have a question or no?
So you have to find the common denominator for the numerator.
Well, in this, you were subtracting fractions. So if you're subtracting fractions, don't you have to get a common denominator? So what if can I erase this or do you guys need this? Can I erase this? Whenever you're I don't care if it's a complex fraction or what, whenever you're adding or subtracting, whenever you're adding or subtracting fractions, you have to have a common denominator. That's what you're seeing me doing. You're seeing me get a common denominator on the top. So basically I'm treating them as two separate problems, but I'm working them simultaneously all the way down. Okay, I have time for one more.
Can you do another complex fraction?
Yeah. Let's we can do 61. So you have 1 plus 1 over x on the top, so you're going to need a common denominator. And then on the bottom, you have 3 minus 1 over x, so you're going to need a common denominator. So the common denominator on the top is x. So you're multiplying the top by x over x, and the common denominator down here is also x. So in the numerator, you get x over x plus 1 over x. And in the denominator, you get 3x over x minus 1 over x. So you got your common denominator, which is x. So that would be x plus 1. And on the bottom, your common denominator is x. And you would have 3x minus 1. So now you take the stack and lay it out flat. X plus 1 divided by x divided by, that's what that big bar means, 3x minus 1 divided by x. So now we change the division to multiply. And you take the reciprocal. Now you can cancel whatever you want. So you notice we can cancel an x. So the answer is x plus 1 over 3x minus 1. And you can't cancel anything. Can't cancel parts of a sum or a difference. So what would the excluded values be? Well, you can't have a 0. And you can't have a positive 1/3. So 0, they're not asking for the excluded values, but if they were, that's what be the excluded values. Can't have a 0 and can't have a positive 1/3. Okay, can you guys show me a thumbs up if you get this? You get what's going on? You understand what's happening? Yeah. Kind of, sort of, not really. Okay, go ahead. I'm going to take questions then. What's confusing you here? What do you need help on? Step number 1, step number 2, step number 3.
Step number 2.
Okay. On step number 2, we're getting a common denominator. So if you had something like 4 minus 7/8, isn't 4 over 1? So wouldn't we have to multiply this by 8 over 8 to get a common denominator? Like if you had a 2 minus 1/3, wouldn't you have to multiply 2? You could write 2 as 2 over 1. But wouldn't you have to multiply this by 3 over 3 to get a common denominator? So wouldn't this be 6/3 minus 1/3 is 5/3? So that's what I'm doing. I have to add 1 plus 1 over x, so I'm multiplying by x over x, which turns out to be x over x plus 1 over x. And on the bottom, when I multiply by x over x, I get 3x over x minus 1 over x. So the top would be x plus 1 over x, and the bottom would be 3x minus 1 over x. And then I take the stack and lay it out flat, because this bar means division. Does that help, Mark, or no?
Yeah, it did. Thank you.
All right. Anybody want to ask me anything? Class is almost over. Okay, well, let me go.
From what
Go ahead.
step did you get the 1/3, Miss Birch?
1/3.
Yeah, when x does not equal 0 and then 1/3.
Yeah, this was on the bottom, it was 3x minus 1. And so if you take 3 times the third minus 1, that's 1 minus 1 or 0. So x cannot be 1/3.
Oh, okay. Okay, I understand.
If that confuses you the way I'm doing it, just take 3x minus 1 and set it equal to 0. 3x equals 1. Divide by 3, x is equal to 1/3. So x cannot be 1/3. Okay, so you are going to struggle with this. I never said it was going to be easy. So we are successful through our failures. So as you're like, why am I doing this? Why am I doing this? I can't even do the work. It takes me an hour to do a problem. By failing, you're going to be successful, because your failures are not a reflection of your intelligence. So it's okay to have trouble, because through the trouble, you're going to be successful. You're just going to have to trust me on that, but I do know what I'm talking about. So anyhow, I hope you have a great day. I don't want you to give up and get discouraged. I want you to spend an hour on this today. You're going to try to work the problems. If you fail, pick yourself up and try again. Keep trying, keep trying, keep trying. And through our failures, we're going to learn this. All right. All right. If you want to hang out with me for a minute, that's fine. Have a great day. Okay. Have a great day. I'll see you later.